Well, good morning, good afternoon, good evening, everyone, wherever you find yourself in the world today. Welcome to this, the penultimate webinar in the SciFest Africa Virtual National Science Festival. My name is Anya Fourie. I'm the Project Director for Broader Impact at the US National Radio Astronomy Observatory here in Charlottesville, Virginia, USA. And I'm a big fangirl of SciFest Africa and our two webinar speakers today. But before I introduce our topic and our speakers, some housekeeping. Please note that all webinars for the festival are recorded for upload to the SciFest Africa website and archives. And if you have any questions for our two speakers today, please pop them in the Q&A box if you're joining us via Zoom, not in the chat box, please in the Q&A box. And if you're joining us via Facebook Live, please add your questions in the comment section. And those will be moderated by our team at SciFest Africa. So on to today's topic. 1 year ago, on 11 March 2020, the World Health Organization declared COVID-19 a global pandemic. 3 days later, the Johns Hopkins Center for Health Security here in the USA warned that hospitals in the country were not prepared for the pandemic, and they predicted that the national stockpile of ventilators will fall far short of that would be required by probably 50,000 units. Now, barely 2 weeks later, by the end of March 2020, hospitals in COVID-19 epicenters like New Jersey found themselves with ventilator shortages. I don't think science has ever before played such a critical and highly publicized role in the well-being of society. No effort could be spared, not only to find a vaccine for this virus, but also to catalyze and accelerate the innovation that was required to find solutions for what seemed like endless and unforeseen impacts of the pandemic. We saw that industries completely unrelated to the health sector, such as Ford Motors and General Electric, suddenly found themselves needing to pivot, having to collaborate and innovate to address a global health crisis. Now, one of the most inspiring stories of this type of innovation comes from the USA's National Aeronautics and Space Administration, lovingly known as NASA by just about everybody, that pivoted from the implementation of mega space science projects to the design and prototype of a high-pressure ventilator in just 37 days. It's my pleasure to welcome Dan Goods, who will tell us about this story today. Dan is a visual strategist at NASA's Jet Propulsion Laboratory, otherwise known as JPL, in Pasadena, California, here in the States. And Dan leads something called The Studio, an extraordinary team of designers, artists, makers, strategists, thinkers that transform complex scientific concepts into meaningful stories that give everyday people like you and me a sense of awe about the universe, and that helps scientists and engineers imagine what the future will look like and, design solutions for that future. The studio has produced well-known NASA multimedia products, from Visions of the Future, which is a series of travel posters that market planets in our solar system and exoplanets, as holiday destinations. Many of you will have seen, for example, the Kepler 16b poster, to High Juno, the project that sent a globally coordinated message to NASA's Juno spacecraft, art installations, such as Beneath the Surface, that allows visitors to experience the atmosphere of Jupiter, or Orbit, that pairs the trajectory data of NASA's satellites with surround sound and allows visitors to listen for and pinpoint exactly, the orbit of a NASA satellite at that exact moment. Dan is also part of creative teams behind familiar art installations. For those of you in the States may have seen Airfield, which is a dynamic sculpture in the Atlanta Hartsfield-Jackson International Airport, in which each flight that lands or takes off from the airport actually activates the visual behavior or movement of the sculpture. But, my descriptions really don't do justice to the work of Dan and his colleagues. So for more about the work of the studio or Dan's work, please visit the websites which the SciFest team will place in the chat window. Dan was recently honored with NASA's Exceptional Public Service Award, and he was selected as one of the most interesting people in Los Angeles, I say in the world. And it's a great pleasure. Welcome, Dan Goods. It's lovely to have you.
Thank you, Anya. Boy, you've done your homework, so thank you very much. That was really awesome. And just thinking back, I can't remember exactly how many years ago it was, but hopefully, if my screen shares here, you'll be able to see it. You and SciFest and South Africa made a huge impact on my life. This was me with some other folks there that got to come by way of NASA, and got to spend a couple of weeks with all you folks and give lots of talks and do demonstrations and various things like that. It was such a beautiful moment in my life. I'd never been to Africa before, and afterwards I got to drive the coast, and so I have very, very fond, amazing memories of being there with everyone. Amazing country and amazing people, and so excited that Freddie called me up to ask if I could give some sort of talk. So so just a little bit of background. So live in the US. I live near Los Angeles. Right now I'm in my garage. And I live right next to JPL. The Jet Propulsion Lab is part of NASA. There's lots of different NASA centers. You've probably heard of like Houston. That's in Texas, and that's where the astronauts are. You might have heard of Kennedy. That's in Florida, and that's where we launch things from. So hopefully sometime the next year, there's going to be the largest rocket ever called the SLS that would be launching from Kennedy. There's multiple other NASA centers, and they all have their own special sauce, their own special unique talents and gifts there. But this is our spot. And so we're nestled right below the foothills in Pasadena. It's a large campus. There's 7,000 people that work at the Jet Propulsion Lab, and they're doing all sorts of things. And hopefully, well, one way I think about JPL is I think of it as a small city with a whole bunch of entrepreneurs, because there's a whole bunch of people there that have ideas, they have dreams, things that they want to do, things that they want to study. They want to understand more about the universe. They want to understand more about things that we just don't know anything about. They have technologies that they want to try out on worlds far away. And it's a really dynamic, exciting place to be. And hopefully you guys got to see this. This is real footage of landing on Mars just, a couple of weeks ago. And it was a super exciting moment for us to be at the Jet Propulsion Lab. Our friends are the ones who worked on these different parts. This was the first time ever that we've ever been able to see the actual landing on Mars, because we've never had cameras for that specific purpose before. And it turned out spectacularly. And, this system of landing on Mars is called the Sky Crane. It's insane. There are so many different parts to it. Every time this happened, this is the second time now that they've landed on Mars in this particular way. I just can't believe it. It just blows my mind that it actually works. So we're pretty well known for landing on Mars. We've landed on Mars a number of different times so far, and it's not easy. We've had our failures, and but fortunately we've been able to keep trying. And this next rover called Perseverance, you're going to learn a little bit more in another talk by my colleague Ashite. Excited for him to be speaking at SciFest. But basically, it's going to be picking up rock samples and putting them in little tubes, dropping them off on the ground. And then in a few years, another spacecraft is going to get there, land on Mars, pick up those tubes, put them inside of a rocket, shoot them off into space again, all the way back to the Earth. Another spacecraft is going to pick up that little spacecraft and then bring it back to Earth. We're partnering with a European Space Agency on that mission. It's insane, but that'll be the first time that we'll actually have, we will have brought back rocks from another planet. We brought back rocks from the moon, but we've never brought back rocks from another planet. So it's exciting, and hopefully someday some of you might be involved in those missions. We do a whole bunch of other types of things. There are many telescopes that are up in space that are looking at stars and galaxies that are really far away, helping us find planets around other stars. It's wild. I remember when I first got to JPL, we had found maybe 100 planets around other stars, but now we believe that every single star that you see up in the sky most likely has a planet, if not a solar system, around them. So that's super. I love that, thinking about that, of all these worlds that are out there. But also, people don't know it, but a lot of our budget at JPL, 1/3 of our budget, actually goes to helping us understand our Earth. This little animation here kind of shows you the 19 different satellites that are flying around the Earth. And if you look up Eyes on the Earth by NASA, you'll be able to click on each one of these, and it'll tell you a lot about the spacecraft, but also give you the live data, the most recent data that we've gotten from space about carbon dioxide, about all sorts of different aspects of the Earth. And so these 19 satellites help us understand our land, whether it's earthquakes or storms, helps us understand the sky, as well as the seas, whether how much sea level rise there is, how much salt there is in the ocean, which affects the way in which water moves around. So JPL, again, I'll come back to this picture a couple different times. A lot of people there doing a lot of different things, and it is like a city because there are plenty of scientists and engineers, but they're not the only people that are there. There are business people there. There are people that are good at logistics. We have lots of things that we need to move back and forth, but there's also a little group of people that I lead that are artists and designers. And this is my team. We call ourselves the studio. And some of them come from graphic design backgrounds. Some come from animation. Some come from advertising. Some did special effects. And we do all sorts of different things there, from helping them imagine and brainstorm missions that are in the future, ones that they want to create, and they need to come up with, they need to figure out what their story is, so they can then use that story to hopefully get funding to someday become a mission. And it's been an honor to be able to be a part of a couple different missions that are in space around another planet right now. There's one called Juno that's at Jupiter, and many years ago, I got to be part of the team that helped pitch that mission, and now there's a spacecraft around Jupiter right now, which is really exciting. But then we also do a bunch of things that we call, well, that first half we call helping people think through their thinking. And it's the idea is that you need lots of different viewpoints whenever you're doing something hard. You can't just have only scientists looking at something, or only engineers, or only business people. You need everybody looking at a really hard problem. And we're just one of those voices. And it's been really exciting to be able to be part of that. So we don't know all the details of equations or physics or engineering things, but we ask questions that the rest of the people don't ask. And we help them start to understand their own project in different ways had we not been there. But then we also have this other phrase we call sneaking up on learning. And we love that. It's about creating something beautiful, mysterious that draws people in. And so hopefully when they get there, they start to ask questions, and they're in the mindset for learning. So this is a good example. This is mission control at JPL. So this is where all the information that goes to and from spacecraft that are at the moon and beyond goes through this room. And there's like 40 of them that are out there, not just from the US, but the Europeans, the Japanese, the Indians, even the United Arab Emirates. And I get a live feed from that room of the data, and it causes this sculpture to activate. So when we are sending data to a spacecraft, lights go up. When we're receiving data for the very first time from these spacecraft, lights come down. And the amount of data that's going back and forth is shown by how much light is being shown. So Voyager is beyond the edge of the solar system. That's a long ways away. And it started a long time ago. It can hardly send any data back and forth. And so you would see just little trickles, but other spacecraft are sending tons and tons of data back and forth. And so the sculpture is in the main administration building at JPL. The director of JPL walks by this every day, at least back when we were on the campus. Right now, we're not on the campus. But it would give people a sense of what I would call the heartbeat of exploration, all this information going back and forth. Anya mentioned the travel posters. If you Google NASA travel posters or the visions of the future, these are just some of the posters. David Delgado is on my team, and he led this effort, sort of thinking about, we're finding these planets around other stars, and we're learning more about the planets within our solar system. What would it be like in a couple hundred or a couple thousand or hundreds of thousands of years if we actually got to go to these places and think of them as travel destinations? And so we started to think about them through the lens of a travel agent, trying to think, well, what's special about this place, and how can you go there? And so these are all free. They're online. You can get really high resolution ones. You can print them out like 3 meters tall. So they're really big, and I encourage you to go look at them. And then there's each one is about something that's special about that specific place. And so Kepler 16b, it really does have 2 suns. So what would it be like to live in a world that has 2 suns? If you ever watched the original Star Wars movies, Luke Skywalker lived on Tatooine, and that had a binary star. So it had 2 suns. And so you'd have 2 shadows. And so this is where your shadow always has company. And then there was one funny one here. It's sort of in the middle on the bottom, PSO J318.5-22. It's sort of a lot to say, but it's a planet that doesn't have a sun. So could you imagine living a place that has no sun? So from an advertising standpoint, like, how do you get people to go to a place like that? Well, we have a place nearby that's called Las Vegas, and that's where the party, what does it say? It's been a little while since I've read that one. Where the nightlife never ends. And so, trying to take something negative, not having a sun, and being able to do something and make it into a positive, well, maybe that's the place that we go and let off our steam. And what was really cool is when I got to come to SciFest, I got to put together a couple of workshops, and amazing kids came and created their own travel posters, and it was super exciting. They had amazing ideas. I still show people to this day these different posters that the kids made. Perhaps some of you were those kids some years ago and are watching now. So thank you. It was a lot of fun to hang out with you. I also got to create this installation where I made a cloud. It was this cloud that filled a room, and it was lit up sort of like it was Jupiter. Jupiter, there is no land on Jupiter. There's no place to walk around on Jupiter. It's nothing like Earth. It's gigantic, but it's just a giant cloud until you get really far in, and then it gets really weird when you get inside of there. But I wanted people to have this feeling of what's it like to fly across just the very top cloud layers. And so I was able to do this at SciFest as well. So today I'm going to share about something a little bit closer to home. And, in the US, COVID has had really devastating effects at different times. Right now, it seems, we're all excited about the vaccine. It seems like things are okay, but this is actually really a big moment actually for me. My father-in-law just got COVID just a few days ago. He's in the hospital. He's on oxygen. He's not on a ventilator at this moment, but COVID hasn't gone away. It's still with us. We still need to be careful. You need to wear your masks. You need to, we need to stay socially distanced. So it's still real. But the great story is about these 2 people. These two people, this is Dave Van Buren, Rob Manning, both amazing engineers. Rob actually has had a hand in landing pretty much every single robot that NASA's ever landed on Mars. And they're both just amazing people. And it was really, I think it was exactly 1 year ago today that they met. And they were, well, they've been friends for a long time, but they were going to lunch. And they went to our cafeteria and they bumped into each other, and they were really busy. You know, Rob had to land on Mars in a couple of months, and Dave was working on a whole bunch of really important engineering tasks. But they bumped into each other and they said hi, and it was right before, you know, everything got shut down. And they had actually been reading quite a bit about the pandemic and how it might really affect the world, and especially, you know, the United States. And then they also had heard about that there might be this shortage of ventilators, as was mentioned. And so, you know, first they were just talking about work, and then they were, you know, getting a little bit more somber about, like, we felt this big cloud about to, you know, come over. But then they asked a really powerful question. They asked, is what I'm doing right now the most important thing I can be doing? I'll say that again. Is what I'm doing right now the most important thing I can be doing? And again, they were doing important things. But what happened was that weekend, so that was a Friday, that weekend, Dave just couldn't get that question out of his head. And over the weekend, he assembled a team, he found some funding, and on that next Monday, the team got together with a doctor who'd been working on ventilators for decades and came to JPL to tell the team everything they needed to know about ventilators, what worked, what didn't, and what was the most critical elements that were specific just to COVID-19. Now, the people in that room, I was not one of those people, were asking themselves a question that everyone else is probably asking, like, why in the world are you working on a ventilator? And what makes you think that you can work on a ventilator? I mean, you guys make spacecraft that go to other worlds. You've never even heard of a ventilator until that day. We've never worked on medical devices. But Dr. Gagarovich, they call him Dr. G, he kind of brought up a whole bunch of really interesting points. And he said, you know, a ventilator, it needs to sense and respond to a body, the human body. And JPL makes really, really intricate, sophisticated instruments that sense and respond to other bodies. It's just that these other bodies are planets and stars and galaxies. Ventilators need to work in really harsh environments. You know, they need to work in a hospital. They need to be able, like, water needs to splash on it, fluids of all kinds need to get on it. When people are in a hurry, they're going to be banging these things all over the place. And if there was a huge surge, you know, you may be in tents outside, you may be in bad weather. There's all sorts of different things. So a ventilator needs to work in a harsh environment. But our spacecraft need to work in harsh environments as well. You know, we've been sending things to places that are colder than it'll ever get on Earth, hotter than it'll ever get on Earth, in worse radiation and in the worst circumstances you could possibly imagine. And our things need to work there. And to that point, you know, a ventilator just needs to work, because if a ventilator stops working, a person can die. And so, you know, if we think about what we do, we send things to other planets, and we can't go there and fix them. There's no one, you know, there's no handy person to kind of go and work on something if something doesn't work. And so we test and we test and we test here on Earth to prove to ourselves that everything that we send to space is going to work. Doesn't always work, but most, you know, things have been working out recently. But the biggest difference is that our machines, they're not hooked up to people, right? And our things are really different. They're just machines. And, you know, if our machine dies, we will be sad. You know, some money will be lost. There'll be, like, less information that we'll get, but it's not a human being. And this fact was not lost on this team. It just made the team more determined than ever to do everything right. So just a little bit about ventilators. They're really expensive. The ones that have been out, at least up until this point, they're very sophisticated units. They're really expensive. They have a whole lot of parts. And they can do a lot of different things. But the team decided that they wanted to create something that was simpler and less expensive, some sort of device that was focused specifically on COVID-19, because that's all we cared about at the moment. It didn't need to do anything else. So that if hospitals had a bunch of these that were, easily mass produced, inexpensive, that the ventilators that they do have could be saved for other types of uses for the people that actually needed them. And so the team put together this little set of rules. And it was really important to think about that when they were first starting. It's like, what are we trying to do? We need to do this fast, right? And when you're running a million miles a minute, million kilometers a minute, sorry, I'm using our standards, you got to make sure that you're focused. And so these were our 4 rules. Everything that we did, we look back to this and go, are we following the rules that we set up for ourselves? So number 1 is do no harm. And what we meant by that is that there are other people trying to make ventilators, like the sophisticated kind that are can do a lot more things. Whatever we do, if thousands of ours are being made, we don't want to stop anyone. We don't want to hurt anybody's effort to make a ventilator. So everything that we do, every part that we put inside of our ventilator has to be something that is not in the supply chain of a normal ventilator, because we don't want to stop them from making their ventilators. Second was use as few parts as necessary. Keep it super simple. Simpler is better. Simpler is better. Just, as long as it does what it's supposed to do, it needs to stay. Don't do anything else. Keep it simple, because we don't have time to think about it. We have to make this thing fast. And then make sure that whatever we put in this thing is not one of the things about JPL is that we make one-of-a-kind objects. We don't make, duplicates. And we tend to have the luxury of making some widget that took someone 3 years to make, because it's the perfect thing that will sense something on Mars or around a planet around another star. But we need to retrain ourselves to go, no, whatever we put in this box, you got to be able to buy this anywhere in the world. And it's got to be easy for people to buy this anywhere in the world. At this moment, when we were making this, nothing was opened all of a sudden. and so it became, our supply list became really small, like, are we going to put a screen on it, or are we going to put LEDs on it? Well, there's only like 5 LEDs that are available right now. And so we got to use those LEDs. And then the last one is make sure it's easy to use. And this is so important, because it doesn't matter how perfectly engineered, how well this thing works. If the person, the doctor or the pulmonologist or whoever it is that's pressing the buttons doesn't know how to use it just like that, then it doesn't matter at all. They're not going to use it. They're going to use whatever they have been using, because they don't have time to deal with that, because people will die if they start to, they don't know what button to press, or a light is flashing that I don't understand, or it's making noises that's weird. And that's actually where our team ended up getting involved a lot more. So what was interesting was that I wasn't a part of this first week. I was at home. Everyone had to go home. Again, there's 7,000 people at JPL, and only 200, or there only about 200 were allowed on the campus, but there's only like 10 people as part of this team, because the rest of the people were actually frantically trying to get Perseverance rover and the helicopter ready to to launch to get to Mars. And so I was at home and I got this crazy email, and someone from this ventilator team said, "Hey, Dan, could you come be a team culturalist on this ventilator team?" And I'm like, team culturalist? I have no idea what that means. Team culture, maybe that's what it means. I don't normally think of myself as a team culturalist, but you know what? I'll do anything I can to help this ventilator effort. I want to save people's lives somehow. And so again, showing you this picture of this large place. Again, there's only 200 people. It seemed like a giant ghost town. And I went down to the room or the area of the building that I was supposed to be in to meet everybody. And this is what I was met with. There were like handwritten signs all over the place. There was flashing lights. There was sign-in sheets. Like I was scared all of a sudden, and I was nervous anyways, right? I was safe at home. But now I'm going to go in and I'm going to be around a bunch of other people. Made me a little nervous. This is before masks became sort of mandatory. We didn't know if we were supposed to use masks or not use masks. How close can we be? How close are we not supposed to be? This is all, very raw and emotional at the time. We even had these little, you'd have to go into the bathroom and wash your hands before you went any further. And then there'd be this little sticker, and every day there'd be a different sticker that you'd have to put on your badge to prove to everyone that you had washed your hands before you came down. And so the first thing is I realized that, all these people are in different rooms, big campus, they're all in different areas because they don't want to be next to each other. But they couldn't see each other and they were having a hard time connecting. And so I like computers and cables and, webcams and stuff like that. And so I went around the campus and I scavenged computers from all over the place and cords and cameras and whatever I could find. And I hooked up all these things so that everyone could see each other. And that was actually a big deal because they needed to be able to communicate and just sort of see the different labs that people are working in. And so, I was just trying to find anything that I could do to help. They didn't really have a plan for me. And then as I was starting to put up these cameras, I realized, this is important. I mean, this is a big deal. The pandemic, what's going to happen? And is there any, this is going to be like a historical event, and perhaps someone needs to be taking pictures. And I love photography. I take a lot of pictures. And so I just started to get to be, I sort of like maneuvered myself into different areas to be able to take pictures of important moments. And so the top left, this is Michelle. She was working on this fan. It was the first time the fan worked. She was super excited. And I got to take a picture of that moment. They down below, they were tearing apart a vacuum cleaner and they were testing it out. On the right, they got some equipment, upper right, they got some equipment working. And Dave Van Buren's there like, yes, we're getting it to work. We can't believe it. And over time, I developed a good relationship with all the people. At the very beginning, they were skittish. They're like, who is this guy with a camera? Why? And actually, it's not one camera. I set up like 10 cameras all over the place. They're like, why are they doing this? I don't like this. I'm nervous as it is. But we started to have this really good relationship and started being able to take pictures of all these special moments. And then I could send these off to the rest of the team because 90% of the team were not there. They were all at home in their, pajamas, working off of their laptops, all alone, right? And yet there's this whole team that is working together and doing different things. And so as I would take these pictures, I would send them off to the rest of the team so that they could feel like they're a part of it. And it was amazing just what that did for the team morale of like, oh, I can't believe, look at that piece. Oh, I've been drawing this in CAD and now it's in real life. And oh, those lights are working. And so it really helped all the people sort of feel like they were part of it. But this was an insane time. Again, we were trying to get this thing done as fast as possible. So basically we worked 24 hours a day, whether it was 2 p.m. or 2 a.m., it didn't seem to matter. We were working all the time. We were working weekends. We were all exhausted. And just an example of how this would go, the chief engineer said, hey, we need to have an interface, we need to lay out the buttons and how this thing's actually, how a human is actually going to interact with this ventilator. Can you do it for us? And we're like, yes, we can do it for you. And he said, great, you have until 6 a.m. in the morning and all the buttons have to stay in exactly the same spot, but you can use whatever colors you want and design that you want, but it needs to be done by 6 a.m. And we're like, what? And so we called up a whole bunch of doctors across the whole United States. We had people on the West Coast, the Midwest, and the East Coast, and we all got together at 8 p.m. our time that night, which is midnight for other people. We asked a whole bunch of questions. How do you use this thing? What's important to you? How does it work? And basically some person ended up staying up all night, and by 6 a.m. he had a prototype that was being able to be used. And we iterated on this more over time, but that sense of urgency that we have to get it done now, we have to get it done now, we have to get it done now, was all permeated through everything that was going on. And so for the engineers, is even worse. They were doing that every day and trying to get these things to work. They're normally they have a plan and then they follow the plan, but in this case they were trying to plan and prototype and create the real thing all at the same time. There's hardware, and that needs to work based upon software, and the software doesn't always work with the hardware. And then this is Dr. G in the center, and another doctor from Mount Sinai Hospital on the left that's in this little computer, and he was in the epicenter of the New York pandemic. Like, people are dying all over the place. In New York, he worked in one of the craziest hospitals. He would literally come out of the hospital, out of the emergency room with his smocks on and talk to us about this ventilator and help us figure out whether or not it's working or not. Really, amazing moments in time there. And so we wanted to make sure that whatever we do is done right. And so behind the scenes, we had, perhaps, if not tens, if not hundreds of advisors helping us in different areas. And that's one of the things about JPL that we're really good at, is it's called systems and engineering. And it's really looking at an entire system and trying to figure out, like, when you turn this knob over here, how does it affect these things over there? And so that's really important, because you could turn this knob and something could totally not work over there, or you could turn the knob and it doesn't really affect the whole system. And so we're working with a whole bunch of different people to help us figure this out. So after 37 days of hardly sleeping at all, these people had stayed up all night, basically in the morning, they finally got it to work. They were super excited. They said, okay, you have like 15 minutes to take pictures. Take the picture. I took the picture. Then they started to wrap the whole thing up, because then they were trying to send it to Mount Sinai, which is where Dr. Levin is, to be able to have it tested on a real, it's a human simulator. And it was so exciting that day, getting to see this thing that we'd put so much energy in, and it worked. And then we were able to send it to another hospital that had another type of thing, and it worked. And they were able to take it right out of the box, start using it right away. They understood the interface. They didn't need to be trained on it. And it's been super exciting. So now we have 2 ventilator designs that are done, and this is the entire team. And one of the things that we did is that we don't make a whole bunch of these things, right? We only make a few things. And so what we did was we created a license that if people could prove to us they could make these things, then we will give them this license. We'll give them all the plans. We'll mentor them, tell them how to do it. And about 27 organizations around the world, some of them are in Brazil, some are in India, one's from Nigeria, and we're going to hear from that team in a couple of minutes. And so other people are making these things around the world. The teams in Brazil have already made like 50 to 100 of them. So it's really exciting because, again, the pandemic's not over. And this all started from that really important question at lunchtime between Dave and Rob Manning, is what I'm doing right now the most important thing I can be doing? I'm going to finish with this 2-minute little video, and then we'll have Q&A.
We are designing an easy and rapidly mass manufacturable ventilator device, and it is a crazy project.
This crisis is unprecedented in our lives, and it requires unprecedented action.
I'm so amped up. I mean, it really, the adrenaline rush, it's exciting, but it's exhausting. And I think we all just want to do everything we can to try to help.
You ready?
Yeah. Oh, very cool. That's awesome.
I would say the biggest personal challenges that I have myself is I don't have time to sleep.
I think what JPL brings to the table is extraordinary talent. It also brings to the table tremendous innovation. The third thing it brings to the table is tremendous focus. The other thing that I felt, I see it in our team, and that is a call to duty. I have this talent, I'm an engineer or a scientist, I can do something.
We have the potential to save human lives, people that we might know, our neighbors, our families. And that intensity, amazing. It's amazing. And as stressful as this has been for everybody in the last couple of weeks, not one of us can stop.
Thank you very much, Dan. Right, well, it's as Dan mentioned, we're now going to bring in a wonderful man by the name of Fulabi Esan, who is a partner at Adlevo Capital, a private equity fund in Nigeria that targets expansion stage technology enabling ventures in Africa, and is behind the production and distribution of the NASA JPL ventilators in Nigeria. Fulabi has over 20 years professional experience establishing new businesses in Nigeria. Prior to Adlevo Capital, he founded Catalyst TDC, a venture incubator that advises clients on technology adoption issues within their companies. He was also the managing director of SAP West Africa and founder of Eureka Consulting, a marketing firm that provided consulting services to small and medium-sized IT companies in Nigeria. Fulabi has a B.Eng in mechanical engineering from Ahmadu Bello University, as well as 2 master's degrees, one in manufacturing systems engineering from Stanford, and another MSc in innovation management and technology policy from the University of London. Fulabi's goal is to contribute to the improvement of livelihoods by facilitating the creation of fulfilling jobs. Welcome, Fulabi.
Thank you very much, Anya. Very nice to be here.
So the first question that I have, is both for Dan and Fulabi. And, Dan, you're an artist, your background was in graphic design. Fulabi, you're a venture capitalist. And, one of the things that we always try to promote at SciFest Africa and at the NRAO is that you don't necessarily have to have, a physics or engineering degree to end up working in the science sector. So, Dan, I'm going to start with you. How on earth did you end up working as a visual strategist and a team culturalist at JPL? And then, I want to ask Fulabi the same thing. How did a, venture capitalist end up working in ventilator production?
Yeah, so I went to a school that happened to be nearby, and to an art school. It's called Art Center College of Design, and we're actually run by Caltech. So California Institute of Technology is a university in Pasadena, world-renowned sort of place. And I'd never imagined in my wildest dreams that I'd ever get to hang out there, but I ended up getting to do an internship there, and really fell in love with being around scientists because because they have big ideas. And I thought, wow, I want to be around these people. And I ended up getting a brief moment to meet the director of the Jet Propulsion Lab. And he gave me an opportunity. I was given 6 months, and that was about 18 years ago. And it's just, you know, I've been really, really fortunate. Again, I think the idea of being a city of entrepreneurs is a place that's ripe for people that want to do something new and different and unique. And that's what I've always wanted to do is be able to do those types of things. And you know, it took a little bit of time at the beginning to get people to trust and believe that, you know, like, why should we pay this person versus another engineer? But I think they really found the value in having different voices and people that could, you know, do things that they can't do.
Folabi, how did you end up here?
Well, it's an amazing coincidence because 30 years ago, I was working in San Francisco with a good friend of mine, Jan Sherman. And Jan called me up early in the pandemic, I think was, you know, probably sometime in March, about a year ago. And he said, hey, a friend of mine is working at JPL, and they're building this ventilator that should be useful in markets like yours in Nigeria. Do you know anyone who would like to build it? And I said, well, Jan, you know, you're calling me because, you know, I can't resist this, right? I mean, I had just come back from Milan and I was hearing all the news and I was figuring out how many ventilators we had in Nigeria and thinking, well, you know, if things really get bad with this virus, then the ventilator is the very last thing that you need. I mean, everything up until needed a ventilator was survivable, but if you need a ventilator, you don't get one, then that's the point where everything falls apart. And so I thought to myself, that's the point where we had to get involved. And then suddenly Janice called me from San Francisco and saying, hey, we have a ventilator design being made at NASA. Would you like to take it on? I'm like, yeah, of course. And it turns out that his friend working at JPL NASA is Dan Goods. So Dan knew Dan and knew me. And this was well before anything really became licensed or anything like that. And Jan said, would you like to be involved? And I said, yes. So I put in the name of our company and said, we'll try and put a team together. And, you know, one thing led to another. They got it going, they got it licensed, like authorized in the United States. And then they put out a call for companies to apply to get licenses to build these ventilators. You know, and the strange thing is, of course, you know, I don't know anything about ventilators. I didn't know anything about ventilators, you know, a year ago. But
we said the same thing.
Exactly, you know. I just thought, well, we just need to get something going. So the first application was just saying, yes, we're interested. Yes, we're going to find the money. Yes, we're going to find the people. Yes, we're going to do whatever it takes to get it going. And you know, the amazing thing was, you know, once we got going, I found this incredible person who was actually like 1 kilometer away from where I lived. And it turned out that a guy called Peter Friedman, an American guy who was a Stanford grad, and you know, we didn't meet at Stanford. I didn't even know him, but suddenly when I was talking about ventilators, I saw he'd written some of ventilators. When I looked him up, he had built a ventilator 17 years ago during the SARS epidemic while at Stanford, and gotten a patent for it, a low-cost ventilator. He lived 1 kilometer away in Lagos, Nigeria. I'm like, you know, how crazy is that? And, you know, so I reached out, found a way to connect to him and said, look, Peter, you're here because of this. You know, you're not in Nigeria for anything you think you're in Nigeria for. You're here because we have 100 ventilators in this country, and we probably need 20,000. And so we need to build some. And here's what's going on in JPL, NASA, and Caltech. We need to get on this boat. And so we put together this team and this proposal and sent it out to JPL and got to talk to Dan and to the team there. And eventually we were awarded one of the licenses. I think that was like June, late June or early July last year. So that's how I got involved.
And, you know, looking at the production and, you know, and distribution of these ventilators, I mean, how big is the team? You know, how many people were employed in making the ventilators? You know, one thinks that it's this enormous operation of like, you know, 800 people that's going to be involved. But, you know, how many companies were involved? How many people?
Well, it started out like a very small team, and we knew we couldn't have a big team. There's not many people we could bring in Nigeria, actually. So we started out with about 10 people on the team, and we knew we'd have to outsource everything. And the beautiful thing about the ventilator that was designed is that, like Dan explained, it's from mainly off-the-shelf parts. So you could buy the parts from, most high street retailers, and then you do an assembly. But we had to make some of the things locally as well. So the team itself is really small, like 10 people. We have amazing people for logistics, for biomedical engineering and the science there. So the business person, we have the director of technology, we have electronics and firmware engineer, and another mechanical engineer who does the sheet metal and stuff and things like that. And then most of the other work is outsourced, so we just have to control the supply of parts into the line. So it's still work in progress. We haven't totally cracked it, because we did find after a while that there were some parts that were more difficult to find than others. And we've now had to, for example, go as far afield as Greece to obtain some parts, because they came in scarcity of the parts at some point in time. But it's been a huge learning experience, and a fascinating one, and a great one for all of us involved. And I think really we learned a lot, but we're also very, very grateful that we didn't have such a terrible pandemic experience in most parts of Africa. So, I mean, in Nigeria, we've had far fewer deaths and serious cases than we expected, which has been a real blessing, because we definitely would have needed thousands more ventilators than we actually do have. So very, very fortunate in those parts. Yeah.
And one of the things that I loved about listening to you, so just sort of backing up, it was really beautiful to see that JPL was willing to listen to whoever, right? Like we didn't know who could do this thing, and everyone was like, well, I know somebody, and I just happen to know this guy named Jan who knew Falabi, and otherwise we never would have had a ventilator license in Africa, and so that was really beautiful. But while we were talking about it, I remember we were always wondering ourselves, like, if we make this thing, is because at that time we thought, oh, this thing will be over in like 2 months, right? But it obviously didn't get over in 2 months. And
if only we knew.
What's that?
If only we knew.
Yeah, if only we knew. Yeah. So we were we were wondering, is this effort just for naught? Are we, we're gonna make this thing and nobody's gonna need them, but it didn't really matter. We hope nobody needs them, right? We hope that nobody ever has to have one of these ventilators. But what I loved about talking with you was that you saw this, and you correct me if I'm wrong, is that the pandemic is one thing, but you're also trying to build capability within a country that you don't have this sort of capability, and so that's the way that you were sort of pitching this to investors, right? And that's it's so heartening to find out that that they gave you a chance, and hopefully no one gets to use your ventilator, but hopefully it builds a capability for the future in all sorts of different areas, whether it's health or something else.
Yeah, I mean, thanks, Dan, for bringing that up. It's amazing because really when I spoke to doctors and pulmonologists from Nigeria who worked in the United States and the UK, they were the ones who primarily funded the project. So, our investors are doctors who are Nigerian doctors in the UK, Nigerian doctors in the United States, who understood the shortage of ventilators, but not just for COVID. They understood that we didn't have ventilators at all. So that was one big thing. The other thing was, like Dan said, between Peter, my partner, who was the Stanford grad, the director of technology, and myself, we also recognized that we didn't have anything to catalyze the skills and the energy of engineers, firmware people to do things, to make a product. And coming out of Stanford's Product Realization Laboratory and other programs like that, we realized that a project like this had the power and the ability to bring everyone together to drive the kind of change we wanted to see. So we ended up building quite a big coalition, not only with JPL and other licensees. We have a very good relationship with another licensee in the JPL licensee cohort, but also with a university in Nigeria and with a bank. I mean, amazingly, a bank in Nigeria saw the opportunity and said, well, you know, we finance all these hospitals. They can't afford ventilators. We see the need for ventilators. We're going to join you. We're going to finance you. So we have a bank who says, we're going to back you. It's not a loan. We're giving you a grant. The first time I have ever heard about that in 30 years in Nigeria of working. So, I mean, with all these things happening, we had no choice. You know, we had no choice but to, you know, get to it. And just listening to the story that Dan told today, which is the first time I'm hearing the whole story, it's amazing. You know, it's just incredible. And Dan, I have to give all you guys, you know, huge kudos for the work that was done on this project. Amazing work. Thank you.
So, you know, Dan and Fulabi, I'm not sure if you're aware, but in South Africa, you know, we had a similar story where the South African Radio Astronomy Observatory, who built the Meerkat radio telescope, you know, and is the host for the South African part of the Square Kilometre Array radio telescope, was also mandated by the South African government to produce ventilators, and didn't take them 37 days. You know, it was 4 months from, you know, from initiation to distribution. You know, and of course, there are challenges that one faces, you know, when you're talking about that entire process. And I think, you know, anybody who knows the South African procurement, government procurement rules will probably know where, you know, where the biggest challenge was there. But I mean, what were the biggest challenges for JPL, Dan, and, you know, for the team in Nigeria, for Fulabi, in getting this design and prototyping and the production and distribution, Dan?
Well, it was funny. I remember, you know, like we like to tell the story of 37 days to the first working prototype. And Fulabi was like, you know, our doctors, that doesn't like give them warm feelings. When you say that, I was like, we're not going to hook that up to anybody. And we're like, oh, come on, this is great, you know. But yeah, so I think at the very beginning, you know, so we were on lockdown. So like you weren't even supposed to drive anywhere, right? If you didn't have like if your organization was not deemed critical, then you weren't supposed to leave your house. And that meant that like all the stuff that would normally be easy for us to buy, you know, that was when, you know, I don't know if you guys went through this situation, but, you know, like there was no toilet paper anywhere, you know, we couldn't buy toilet paper, we couldn't buy milk, we couldn't buy flour because everyone had bought everything. But this was a little different in that like all these places where, you know, you needed a bolt and you'd think, well, that's easy to get. Well, it's not easy to get. And even if it was easy to get, when it got to JPL, you know, like not everyone was working there. And so we had critical items coming and the security guard turned them away. They're like, oh no, we're not open. And we're like, oh, go get them, go track that person down, you know? And so that was hard as well. I mean, just like I was trying to find those computers and things like that, like the all IT people, they weren't around to help you figure things out, you know? So that was one sort of challenge. But in the process of that, amazing stories happened where we would call up a vendor trying to find, you know, a switch or you know, something like that. And they would say, you know what, we don't have it, but here's the phone number of our competitor, call them up. And that would never happen. You know, that would, you don't send people to your competitors often, but they understood the situation. They're like, you know what, go talk to them. They'll be able to help you out. And so that was really, you know, beautiful moments. Yeah. Again, you know, like one of Michael Johnson, who had mentioned on the video, like, I don't have time to sleep. You know, they, you know, a lot of them just didn't sleep very much. And so we were pretty exhausted. And see, what were some of the other, there are myriad of issues because we needed to get the FDA, the Food and Drug Administration, to give us an authorization for this this thing for it to be usable by other people, or at least for us to feel good about it. And that's a huge process. And if you were to see all the paperwork that we did, like it would fill up this room of paperwork that we had to produce to prove, that what our design was right. Fortunately, they were very responsive, which is not normal for a government agency probably anywhere in the world, right? But they were super responsive and helped us out, many different times. But we had to have, huge, people are staying up all night, again, just like formatting all this stuff so that people could read it somewhere else. And meanwhile, their kids are not at school anymore, so they're at home, trying to live with everyone's family life being upended. So those were some of the things. There are plenty of others. I mean, we were trying to figure out, there's a big difference between what we did and maybe some of the other efforts that were more open source, because ours is a high pressure ventilator, which is different than one that you squeeze a whatever those things are called. But those are all, everything is useful. It's just that this would be helpful in a more serious situation. So just trying to decide which route to go, because as soon as you make a decision when you're running 100 miles an hour, you don't have a chance to turn around.
So, I mean, from our side, you have to remember that we were not making medical devices. We were not making anything. We're not manufacturing anything. Adlivo Capital is a venture capital private equity firm. And, so we're from really literally zero, we had to get people to drop what they were doing, their jobs, and bring a team together from scratch, from nothing. And we had to find money and find people, find the space, convince the JPL that they should give us a chance, and then get going. So for me, that was kind of like a big thing, to see that so many highly qualified people were willing to drop what they were doing and contribute their time and skills and money to a project that really only had kind of like our commitment to it for them to go on. I mean, when we got the license from JPL, a funny thing was when we submitted our license application and all of that, we gave our office address. And one of the people who hadn't been involved in the whole process of interviewing, talking, and so on, hadn't met me, looked up the office address on Google, and then saw that, maybe the place had been occupied by a Chinese restaurant in the past or something. He says, look, what are you guys doing? It's a Chinese restaurant, Can you explain what's going on in that neighborhood? Is that why you're going to be making this ventilator? And, so we had to respond to this query. I mean, it's like, it's the other side of the world. So someone is sitting down in Pasadena is saying, who are these guys in Nigeria who've never built anything, never? And they say they're going to make this thing, and look at where they are, right? Look at where they are. So we had to explain all sorts of things to JPL to start with, to get them to sort of believe in what we're doing. And we had to do the same to people in Nigeria to say, well, Adlivo Capital is, it's a PE company, it's a finance company, but look, I once studied engineering, right? Once upon a time, I did study engineering, and we have these wonderful people who are all committed, and here they've all signed this paper that they're going to work on this thing. And yes, you can give us your money, and we're not going to run away with it, and on and on and on, and to get all this done in a short time, and a short enough time to get the license. So that was a big thing, because, like Dan said, even though we realized that we had a longer horizon for what we wanted to do, if we didn't get it right in that first, say, 60 days, we would have lost a huge opportunity. I mean, what we got from the Jet Propulsion Lab as a basis to build a whole industry, essentially, we would not have had it. What we have today in terms of the information, the know-how, the files, the documentation, the way to go to regulators, what to say and how to do it. I mean, and the team, because JPL also then brought together all the licensees and gave regular briefings and brought everyone together to discuss what they were facing, the problems they were having, solutions to those problems, ask questions, create a portal. And all of that would have been lost to us in Sub-Saharan Africa, not just in Nigeria, but we're the only guys in Sub-Saharan Africa who actually have this opportunity. And we took it almost like a sacred thing that we had to find a way to make it work, right? We had to find a way to reach out to everybody we needed to make it work. So we had, of course, JPL, fantastic. Then we had our funders, like I mentioned, some doctors in Nigeria, some Nigerian doctors in the UK, in Nigeria, in the United States, a bank in Nigeria, university in Nigeria. The Central Bank of Nigeria got involved, and we're still hoping they're going to jump behind us as we go through this. And yeah, all kinds of people. In fact, even many people in South Africa. I had friends in South Africa I reached out to and said, look, we need help here. And they would send down information, send down names of people, give us, it was incredible. So lots of support. In terms of difficulty, well, we found that there was quite a lack of capacity, right? So people, I tell you what was actually most amazing to us. We had to redefine, let's say, quality in some ways. We had these amazing, wonderful drawings, CAD drawings with tolerances, with everything is in there. We'd give it to a vendor. The vendor's used to doing things that are just, well, it's okay. And they'd send us back parts that were, you know, they looked like they were right, but they weren't. You know, when you measured them, they were wrong. And this was because they were used to making a different kind of product. They weren't used to making a medical device or a device where things had been interchangeable. And so the whole process of trying to get people to change their mentality about what it meant to be in spec. And this is something that I think the JPL and other people would just say, hey, that's the way it is. You know, you have to get it right. But we had a hard time trying to make sure that everyone we were working with understood that it wasn't business as usual, that you had to get this thing to the right specification. It is a medical device. It's going to be hooked up to people. And if it's not right, people can die. So that was a whole sea change for us to get people to understand that and to build to that specification. So challenging, but also very rewarding, I think.
Yeah, and you know, great that there is now the development of this new sector, you know, within West Africa and Africa, which is great. So, final question for our session today, again for both of you. You know, listening to all these wonderful stories, you know, that have come out, not just this particular story, but stories about innovation in general during COVID-19. Dan and Fulabi, what do you think is the one good thing that has happened for innovation as a result of this pandemic?
Well, I mean, there are multiple stories, many stories of people pivoting from using, you know, manufacturing or making one thing and doing something else. And so I think sometimes you need a catastrophic event to cause people to rethink what they do, and it's been beautiful to see that all over the world. And people, you know, people who may not necessarily bump into each other or care about each other very much in normal times, all of a sudden did. And I think that that's a really powerful thing that hopefully, you know, despite all the politics and stuff like that has gotten involved, that you know, people still can remember those things.
And the last word from Nigeria.
Well, you know, it's not many times in the world that you have collaboration that involves NASA, JPL, Caltech, and a small productive firm in Nigeria with a bunch of people pull together and join in, a university in Nigeria and a bank in Nigeria, and everyone excited about the same thing. So the connections that were formed and the engagement that we've enjoyed with not only NASA JPL, but with other licensees, support, learning, and just the feeling, I think, that we all have in Nigeria that we can be part of a global innovation movement to get things better, I think has been amazing. I think that, you know, in the end, that our project, if we get something out there, it will help many other projects like ours reach out and say, well, reach out to other people and say, well, we can do this. Let's work together. And I think that to the extent that we succeed, like we all working together at JPL now, then other people have a chance to succeed by sharing the kind of knowledge that exists in these really high-tech environments and bring them to countries like Nigeria.
Wonderful. Well, Dan Falabi, thank you very, very much for your time today. Thank you for joining us. From California, Nigeria to South Africa, Charlottesville, you know, that's, I think, the great thing about this pandemic. Thank you for your time, and please, you know, convey all our thanks to everyone at JPL and at Adlevel for this incredible work that they've done. And as I said, you know, this is the penultimate in the webinar series for SciFest Africa's National Science Festival this year. So, you know, please join us on Sunday, the 15th of March, that's this coming Sunday at 8 p.m. South African Standard Time, to hear about the Perseverance rover, you know, straight from those involved at NASA JPL. From me here in Charlottesville, it's lovely to have spent some time with you. Thank you for joining us. Bye-bye.